with a couple of case studies on where we've used this already and show you some of the benefits. The first case study was a customer that had come to us and said, can you use some of your proprietary data assets, and can you use this new NeuroDecision technology to help our business? Well, this customer is a large retail store, and they sell electronics and appliances, and they can extend a line of credit inside their store to their customers. It's a pretty big organization. And what we did is we took on the challenge here with our Ignite solutions and applied our existing attributes, our ADA attributes, advanced decisioning attributes, and we also applied some new data, right, our trended attributes that we talked about earlier. We also applied in our data sets some of our proprietary utility and communications, our NCTUE. And we also looked at the debt-to-income ratios that are inside of our proprietary Reg Z. The additional data was significant and helped the statistical model performance. But more important than that, NeuroDecision can make use of all of this data, of all of these new attributes, of all of the sample. And as we applied both the additional data and the proprietary NeuroDecision, we got a significant lift in model performance. Now we measure lift in KS, right? KS statistics. The original legacy score of the customer was about 30 KS points. And adding the proprietary data, the additional data, and NeuroDecision, we were able to increase the KS to about 35. And that's a 16% increase. Well, as you know in statistics, that's huge, right? A double-digit increase in KS statistics. But our customers weren't really interested in KS. They wanted to know what it did to their business. And that's where it gets very interesting. By using these better models, right, by using our Ignite configurable solutions, we were able to create for them a new performance model that allowed them to score more customers, 7% more customers for financial inclusion. And for them, that was over 70,000 new approved accounts every year. For them, it was important to keep, right, the risk of their portfolio constant. They wanted to keep their default rate constant. So we showed them how they were able to approve 70,000 more accounts and keeping a constant portfolio risk. But in dollars, it meant to them over $100 million in additional revenue every year. They were very, very happy with Equifax. The second case study we'll talk about is really internally. We've been producing credit scores and different types of products for years. Now we're taking a look at our portfolio, and we're looking at our explainable AI, and we're looking at how we can apply it to some of our legacy scores. So this commercial insight delinquency score is one of our core scores that predicts default on a small or medium-sized business loan. So we went back and rebuilt it. We took the legacy score, which had a KS of about 40 or 41 points, and used our Ignite configurable solutions to use all of the data that we have access to, all of the big data. We don't have to downsample anymore. We then used NeuroDecision to help give us lift in the modeling parameters that Dr. Matt had talked about earlier today. And we also added our commercial trended data. And once again, by adding more data, trended data, and new analytics and machine learning, we were able to get double-digit KS lift. Again, here was about 20% lift in the KS statistic. This is huge, right? For our customers that are now using our next generation commercial insight delinquency score, they will see a significant improvement. And as you can imagine, we're going back through our portfolio and reapplying NeuroDecision to many of our products. So I want to thank you Thank you everybody today for listening to us to talk about explainable AI, to talk about NeuroDecision Technology. Right. We believe that this cracks open the black box of neural networks. It allows us to generate logical and actionable reason codes. And know that NeuroDecision is just one of many innovations coming out of our data and analytics labs here at Equifax. We're using explainable AI and machine learning to really help our customers and help our consumers make better decisions. And we know that NeuroDecision was the first neural network to meet industry regulatory requirements. And we tested that back in 2016 and 2017. And we're using Spark and Scala and advanced machine learning to help us build higher performing predictive models. And we're able to now scale to unprecedented uses in our computing environments. And then finally today we looked at two case studies, one for a customer and one internally here at Equifax. And what we're seeing is that the businesses are seeing increased revenue. They're able to approve more accounts and it impacts their business significantly. So with that, I'll thank you, and I think we'll open up the chat line to questions.
Yes, as a reminder, if you have any questions, please put them in the chat, which is in the lower left-hand corner screen. And we've had a few come in already, and I want to go ahead and read a couple of those. The first one, I think it's for you, Dr. Matt. How are NeuroDecision models specified?
Yeah, so we specify NeuroDecision models as a scorecard of scorecards. So if you're working with an implementation team of developers and they're accustomed to implementing logistic regression scorecards or any type of regression scorecards, they can very easily implement the NeuroDecision models that we specify, because each of the hidden nodes on the input layer is a scorecard, and then our final credit score is just a scorecard of those intermediate scorecards. So the model specification basically generalizes a traditional logistic regression scorecard.
Great. Okay, and then the next one is, does this model estimate the credit score with a score of 350 to 800, or a binary yes/no for credit decisioning?
Yeah, so the output of a NeuroDecision model is basically the exact same thing you get with a traditional credit scoring system. You get a 3-digit score that can be on any range, 0 up to 1,000. Sometimes those are scaled to, for example, a 300 to 850 or a 350 to 800. But you get your 3-digit credit score, and then you also get your reason codes. What were the top 4 things that affected this consumer's score?
Great. And then tell me about multicollinearity. Does that affect NeuroDecision?
It does, but not to the same extent of a logistic regression model. So we know that as you get high collinearity between inputs in your model, regression models become very unstable. And this is that ill-conditioned problem example that we were looking at. It's known throughout the academic literature that multicollinearity does affect neural networks, but certainly not to the same extent that it does logistic regression. Because of that, we're able to actually put more input predictors into our model, which gives us higher performing models and because we overlay the monotonicity constraints, these models tend to be more stable over time than an unconstrained neural network model.
Okay, and I think this question is for Chris. Does every application get a 20% KS lift?
Our customers ask that a lot, yeah. What's important about this is when we start any project, right, we need to look at the data. We need to look at the data set. Now that's true. We showed you 2 use cases today that received 20% KS lift. And we are seeing double-digit KS lift in many of our projects. And clearly, every project we've done to date, NeuroDecision will outperform the traditional logistic regression. And usually the sparser the data, the better neural networks will perform.
Okay, I think we're back to another question for Dr. Matt. The monotonic applies to individual variables. How do you control the interaction term behavior?
Yeah, that's a great question. Let me start with logistic regression. If you want interaction terms in your logistic regression model, you have to explicitly discover the interactions, and you have to explicitly put those interactions into your model. Now, any type of machine learning model, especially neural networks, they're great at three things. They're great at capturing nonlinear trends. They're great at capturing interactions. We like both of those features. And they're also great at capturing non-monotonicities. That's the feature we don't like, and that's the feature that we turn off in NeuroDecision. We still want to capture the nonlinearities in the data. We still want to capture the interactions in the data. But those interactions are captured through these intermediate nodes, through the hidden layers. And it's not something we have to interpret directly because we are generating our reads and codes from the input layer of our model. So we don't have to concern ourselves with interpreting the hidden layer, i.e. we don't have to interpret the interactions and nonlinearities that are happening to the variables in the model.
Okay, and another question is, when building this model, do you need to go through the variable selection process and feature generation process?
Yeah, absolutely. Anytime you're building an explainable model, you still want to get to as simple of the model as you can while retaining as much of the predictive power as possible. When we put all of the attributes, when we assemble those together, all of the attributes in those case studies Chris was showing you, that amounts to well over 1,000 inputs to your model. If you want to actually put a model into production and use it for decisioning in real time, you want that to run fast. You want it to be able to be coded fast. You want to be able to perform performance monitoring and model risk assessment on this model very quickly. Because of all of these factors, having as simple of a model as possible while retaining the predictive power is very important. So yes, we do go through a variable selection process. We may start with 1,000 attributes, but we quickly determine which attributes are of benefit to this model and which attributes can be pulled out. And we try to get to a reduced subset of the attributes. We don't necessarily reduce it as much as one has to in a regression model, but we do get to a subset of our starting attributes.
Okay, and then I think maybe Chris can answer this one. What's the process for model risk management for NeuroDecision models?
Well, want to take that, Matt?
Sure. Because our NeuroDecision models generalize the industry standard logistic regression, nothing really changes as far as model risk management goes. The same procedures and processes that apply to logistic regression apply to our NeuroDecision models. So if we're looking at PSI measures, so how stable are my attributes, the inputs to the models, you still have those same measures on a NeuroDecision model. You still want to make sure your attributes are stable over time. And of course, if the attributes become unstable, it can affect the model performance. You also want to look at the stability of the score over time. Just like with logistic regression models, as the economy changes, you see the distribution of the score shift, just like you would with logistic regression. And you need to monitor those things, and you need to know when is it time to refresh this model or rebuild this model. So from a model risk management perspective, all of the same measures and procedures that apply for logistic regression still apply for neural networks.
Yeah, and to add on to that, I think often we get a question from our customers, right? Often the chief risk officer, and asks us that about model risk management, and if neural networks are different or harder or more complicated? And the answer is no, right? We use the traditional methods that they're currently using, and as we take them through it, they understand very clearly it's the same process for their internal business operations.
Okay, and Dr. Matt, another question for you about the case studies. How many variables were in the final model to get a 20% lift on KS?
That's a great question. Without an easy answer. I don't have the exact numbers, but I can ballpark them. But I want to preface that with our legacy score was just using one set of attributes. But in the new solution that we presented to you today, it had other types of data assets involved. In particular, it had the trended data assets in there, so our time series attributes that we have. So what we're doing is we're combining new types of attributes with new analytical techniques, and the combination of those are what's producing this 20% lift. But now on the actual variable count, I think in the legacy score there were approximately 50 attributes in that model, and I think in the new solution that we have that again brings in additional data assets, there were about 80 or so attributes in that final model.
Great, thank you. And then what if I want to capture a non-monotonic trend that can be explained?
That is a good question.
Yeah, that's a great question. There are occasions where you have a non-monotonic trend in the data, and you can fully explain that non-monotonic trend. So you don't want to enforce monotonicity through this attribute. An example may be if you're looking at card utilization. If you look at card utilization, you know that very low utilization often has a slightly elevated risk profile. So 0% utilization has a slightly higher risk profile than a consumer that has 5% utilization. But then, of course, that trend quickly reverses, right? As you get up to 50% utilization, you're back to being extremely risky again. So it has a U-shape or a parabola-shaped trend to it. Sometimes you may want to incorporate that feature into your model. You can do that through segmentation. So what we do is we segment our model, and once you have fixed the segment, we'll enforce the negative trend on one segment, and we'll enforce the positive trend on the other segment. So if you can explain the non-monotonicity, you can just incorporate it into the model through segmentation.
Okay, and as we go through these other questions, I wanted to let everybody know that we do have 2 videos on NeuroDecision, and they're on YouTube. And if you just go to YouTube, I have the addresses here, but if you just go to YouTube and type in NeuroDecision, they will both come up. Okay, I see we have another question. Is it possible that NeuroDecision models are more volatile than the traditional scorecards in terms of drops in KS or Gini?
Yeah, that's another excellent question. We touched on it a little bit. If you fit an unconstrained model, so not a NeuroDecision model, but if you fit an unconstrained model, the answer here is absolutely yes. And I think we were surprised the first time we saw this, but as we started reflecting on it, we realized it makes sense, and we've seen it a lot of times since then. What happens is if you take an end-time holdout sample and you validate an unconstrained model, of course, it absolutely beats our monotonically constrained NeuroDecision model. The unconstrained model can fit the end-time data better, and if you look at an end-time validation data set, the unconstrained model will beat the constrained model. But what we've seen is that when you start going out of time, even sometimes as early as just 3 months out of time, you will quickly see that the monotonically constrained model actually starts outperforming the unconstrained model. When we first saw this, we were a little bit surprised, but we've seen it over a dozen times now on various use cases that we've looked at. Imposing the monotonic constraints allows these models to hold up over time. It makes them more stable over time. If you fit an unconstrained model, it overfits the data. So anytime the population shifts, even in the slightest, it dramatically can affect the performance of that unconstrained model. And so what we get with these monotonic constraints is we get a model that holds up over time, and it's because we're imposing our expert knowledge onto the system. As I said at the start, once you fix a segment or once you fix a portfolio, almost every attribute that you look at, you can say this is a positive behavior attribute or this is a negative behavior attribute. So if you start chasing negative artifacts and a positive trend attribute, those things aren't going to hold up on time, and it will deteriorate the unconstrained model performance over time.
Great. Want to take one more? Okay. The last question that we can take today is, was this a single hidden layer or a multiple?
Yeah, excellent question. We, in all of our presentations, we visually present just a single hidden layer model just because it's easier to visualize and fits nicely on a slide, and it's easy to talk about the paths between the input and the output just using a single hidden layer. However, in practice, we build multiple hidden layer models. So all of the NeuroDecision models that we're currently putting into production to date leverage multiple hidden layers. And our explainable solution applies to multiple hidden layers. And when we wrote our patent back in March of 2015, we worked out the theory and the patent claims in there to cover the multiple hidden layer case. So we showed the single hidden layer just for easy visualization purposes.
Thank you. And thank you very much, Dr. Matt and Chris, for your time today. And everyone, we're going to end a few minutes early because we do have a survey we'd like you to fill out. It's really about 3 questions, I believe. And thank you very much today, and we'll be sending this replay out for everyone to review if you need to review, and be sure to check out the videos on YouTube. Thanks a lot, and have a great day.